Hi everyone. Um, I have you enjoying your day here in Belgrade. It's sunny a little bit, so it's nice, but it's very cold at night. So I don't know when the spring really is coming. It's really strange. And I'm originally from Egypt, so people in Egypt just saying we are still in cold. And usually in Egypt, we have the winter is just only in, December, January, and February. And then everything for us is like July, 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 July. So it's everything summer. So this year is strange, but let's hope for the best. Thank you for having me in Books Days Romania. And I wish that I would be in person, but the circumstances and everything's running around is really crazy after the pandemic. And now we forget about the pandemic. We have another situation. So I wish everyone from both countries have the peace and let's wish for the good, and let's start with the our session because, to be honest, I love this session and I want to share it with you. I have shared it many, many, many times, or even though I'm doing Java, GDK a lot, talks, articles, a lot of stuff, but this one of the best topic that I always talk about, and there is always misunderstanding, and even it's old topic. It's one of the oldest topics that we have, but there is always when I'm managing teams, I found always like misunderstanding and misinterpretation for the risk design, and the constraint that we're gonna see. So I wanted to point out here for two things. We will get into it. So this is why it's called effective design of RESTful API. Yeah, we have GraphQL, we have everything, but as before, the previous session from our friends Rostom and Anna, they say don't take everything like replacing theirs. No, REST still is ongoing. We are gonna use it for specific purpose of development, and Graph is just managing to solve the specific cases, which is great for that. So it's not replacement. You cannot replace fully because you are going to overcomplicate things which we don't need to. And this is the main problem. Like, let's move to microservices. Let's move to cloud native. Let's use only Kubernetes. Like, do you really need this? Because it's really not an easy. So because of the time, let's jump in. So what we are gonna have from this presentation at the end, we're gonna have to know uh, how we can model our REST API, and when we are modeling and finished, how we can design our system in such a way it's really considering the design constraint for REST API that help our architecture to extend and maintain easily when we would like to grow our business. And this is what I'm doing in my company, actually. One of the things. So my name is Mohamed Taman, as I told you before, and I'm working for Ifortel. Ifortel is a telecommunication company. We are not actual telecommunication company. We are providing a software that make mobile network operator and mobile virtual network operator to run. So this is where you go to some branches and buy some SIM cards or products, whatever. They have a software to manage and CRM and the products and everything. So we are enabling these people to work with such software that manage every single aspect of the telecommunication industry. So, and I have my company in Belgrade, so I'm using it for consultancy. I'm Java Champion, Groundbreaker Investor, which is now we are Oracle Ace, and I'm a speaker. This is why I'm here. Let's jump into. If you'd like to catch me, I will get these slides at the end. So all my projects, all my proof of concept, using like whatever you like, and all my article code is on my GitHub account. So it's my landing page and my blog. Actually, I do everything there. You can have me on LinkedIn and on Twitter, and send me email at any time. Let's get back to our agenda. So what we're gonna have today, we would like to learn about some tips about modeling, and this is very important. And then we would like to know how we can model our system. Who's the main and key participants in our system in order to know? It's like kind of analysis, but this is the main part of our system design. Then, okay, we have designed our system, how we could validate it to make sure that we don't have gaps, we don't have missing requirements. and everything is covered based on the requirement that we have. And finally, we have to learn about the normal HTTP response and payload, and everyone knows, but like don't overuse which ones that we need to serve our design, and that's enough. Because I see that some people, as I told you, overcomplicate and using a lot of kind of HTTP response code and things. We're gonna see just enough what we need to have. And finally, the most important is, yes, we have the APIs and everything, how we can make our system, REST architecture effective, like following the RESTful API architecture guidelines, because we don't have here any kind of, um, like guidelines. Actually, it just experiences that every one of us like have through the work, and then we agreed on same like design patterns. It's agreed upon solution for specific problems, and it's not like that standard. Then okay, when we have this case, we should do it like this. So the best experience and the guidelines that we have to have and should be found in each REST API as much as we can. Not all of them, but if you have it, you are doing a great REST endpoint for your client and will save your time. And also, it's very extendable for your business. So let's jump in without further ado. Let's go to the our design. So it's all about design. So sometimes we have systems either and we need to have some API because we would like to integrate with some modern endpoints and clients like mobile, IoT. We have bunch single page architecture, front end engineering. So we are the services. We are the core of the services. So, but sometimes we have old systems and new systems and current systems. So what we're gonna do? But before we jump in, I would like to just mention that API design is really one of the hardest thing that you can imagine. Like why? Because we have to put in our mind what functionality to expose. This is very important. Not everything, what just the functionality, and then how to expose it, and what is the best way really to expose it, and not to introduce security flows and don't overexpose my data and API, and how then to adjust and improve. So I have to have this information and these questions always in my mind when I'm designing something. It's not just design REST API, designing method, class, whatever it is. So those should apply. And there is, in computer science, there is only two hard things in computer science, as I told you, which is cache invalidation, and we have a lot of argue about it, and naming things. Naming is not an easy, but if you do a proper naming, means self-documentation. And you don't have to write a bunch of documentation about things, because when I have a contract, it's very easy to read and very easy to grasp and get the functionality from just the name. And you have a consistent naming. This is one of the most important also. This is very important. So we're gonna see this. So it's not an easy process. This is why people fail to do it properly sometimes, but it needs some effort. So let's talk about something in human-computer interaction. It's called affordance. So an affordance is something which allows you to perform an action or accomplish a goal. And we will see how to incorporate this with our design. Such as like some design, of the product. If you have a door locker, what is the affordance? Just enough. It's just to lock and unlock the door, and that's it. This is the main function. I don't have to do it to provide for the locker to do more stuff. It just because it's only affordance is to open and lock, the door. And for the switch, for the light, it's only meant to be for switching on and switching off the light, not to hang some of my clothes on it, or to design it in a strange way, but it will not suit everyone, like just the purpose. So this is affordance in computer or design, actually. In practice, so when we apply it to our practice, so what the API really allows you to do, and what the API makes it easy. It's, yes, I will provide the functionality, but how to make it easy. If you have a data that you can infer from some other data, yes, hide it. You don't have to get every thing from the client, and make it easy for them to just subscribe. So instead of like 4 or 5 steps, I can have it in 1 step or 2 steps. Yet it will save your business and the time. So this is the main idea, and what is the user wants to accomplish, because I have to understand to which kind of user I have to allow this and prevent my functionality from the others. Let's talk about like coffee cups, for example. If we have a coffee cup like this because we love coffee, so if I'm designing handler, handlers are great, and it's designed. Why? Because if it's the content of the cup is very hot, I will burn my hand if I don't have handler. So it's easy for holding, can be used for other things. Yes, it's like I hang it in the kitchen, I can make use of it, and it should suit every hand as an average. So this is the kind of design. Getting back, we have REST API. I would like to introduce it, and then why I was mentioning design and naming, because it's very important and it will come into play when we model now. So now I have a requirement, and it would like to add it. So we have 3 approaches here to add an API. Bolt-on strategy. Bolt-on strategy, we call it brownfield project. What is brownfield projects? Actually, this is a current running project that it's, I would like to, I have a backend services that just serve only front end, but this functionality, I would like to expose it to outside, to have a mobile, to have different integrations and everything. So this is like, okay, we are running, let's expose our API to be REST for further integration and availability for more clients to work with us. So it's a broad force approach, but generally is the fastest way to get something useful. And the main problem is we will talk about, here is an advantage that yes, the already system is running. We are taking advantage of the existing code and system, just we are trying to expose it. But the main problem is sometimes we have problems and bugs maybe leak through the API, which we have to take care of. So the most easiest one, which is the nicest one, but we don't have this option always, is the greenfield. Greenfield, like I'm starting an broad project from the beginning. So generally, we start in the mindset of API first. I'm looking for what APIs I would like to introduce, or we call it mobile first mindset. What is the functionality I would like to expose to my clients, and for the purpose of many sources to integration or whatever it is, then I build the back end to serve this. This is very important point. Taking advantage of the new technology definitely, and possibly reinvigorate the team and allow them to work with the new things, and you have into play the latest technology and everything. It's nice, but not always possible to drive business very quickly or easily, because you're starting something, but you have to focus on the client side. One of the things also I have exposed to many times when I was working for the government is facade strategy, because we have a legacy system. I would like legacy systems mainly written in COBOL or written in AS400 for IBM. Or can you imagine this kind of system, not just legacy written in Java from 10 years ago or something like this? No. I'm talking about the banking systems, insurance system, pension systems, taxation. They are having these like pharmaceutical companies, like they have AS400 systems and they have COBOL still yet running, but it's very stable. But I would like to expose, yes, we have kind of integration and everything that we can use, but just we need to wrap the existing logic and replace as you go, and then we have to expose it to outside to allow more modern integration with our system. I have done this, but the main problem when you sit with these people to have the functional requirement, we have different mindset. You are using a new, modern object-oriented programming language and these tools, and it doesn't understand this. So you have to be mindful when you are working with these people in old systems, so to fill the gap. And the challenging here, as I told you, it's the mindset, multiple mindset in the system. So we have to cope with this. So now we know how to add our API. Let's model it. So there is some tips for modeling API, but before we go to modeling, I would like just to lay out 3 simple rules here. One of them, don't worry about the tool. you don't have to say. There is some people like, I would like to have a specific tool to do this. Like we have a bunch of tools. You can have pen and paper, and that's it. I'm usually doing this. And second is very, very important. Have a consistent process. Don't just do it in a different way. You have defining, and we will see what meant by consistent process. And it doesn't count unless it's written down. This is, believe me, if you don't write everything on paper, even you don't have to write it in Confluence, you don't have, because it will take time and styling and things. Just write it in paper, record it for later, because whenever you leave it for 1 day or 2 days, you will lose 20 or 10% of the information you already had. And then what is the problem? You will end up with missing information, you will end up with gaps in your requirement. So document everything, and you can deprioritize everything later. So after that, let's first, how can I model? First, identify participant. Who, like, this is for each participant, we need to capture who they are. Is they are external or internal to the system, so to serve the security purpose, and who's do what, and short description, like persona. When we do like front end UI and UX design, persona about the customer. For you, it's just the functional part and security part and what you need to expose, because sometimes the same functionality for outside person, it would definitely different purpose for serving him than the internal system. The data, I mean, like, so let's take an example to see how we can do it for coffee shop. Like, who are the participants in coffee shop? Patron, which is you, the customer, the cashier, barista, other customers. Yeah, I like coffee, so I'm going to have, we love Java and things, but let's have it always like this. And I'm so sorry for my voice if you hear me not that clear, because I'm really sick. I hold not Corona. So, but you will not be affected because we are virtual. So let's get back. So we have the barista, the people who are serving us, and other customers. Yeah, we need. So let's identify them. We know the people who is going to interact with our system. Then we need to see the activities. From the activities, we are going to break them into steps, and in order to identify the functionality. So what are our activities? This is revision 1, by the way. You place an order, you wait for an order, and you receive an order, right? This is the most important things for me. But to be honest, this isn't complete. It just described me. Why? Because where are the others? What the barista is going to do? Where are the others? So let's revise, and this is a complete. So we have to make sure that, yes, because at the beginning we're listing all the participants, but sometimes not all of them are going to participate to my system. So we can just remove them. We don't have to care about them. Why? Based on the interaction. So the patron, which is you, create an order with the cashier. So the interactivity between the participant is very important for you. The cashier passes the order to the barista. Nice. The barista acknowledges the order and adds it to the queue. And then the orders are processed and inventory and machine are tracked. See, there is something new has been discovered here. Like, we have to make sure that we are, notifying our inventory and machines for tracking. And as orders are ready, they are announced and delivered. This is very important. The customer at the end, which is us, to receive their orders. Nice. So let's take a book and go through the analysis of this book online. So what is the participant here? We have system admin, developers, customer support. So what the activities? I'm not going to have a long one. So we would like to place an order for a book, look at order status, cancel an order, add item to cart, remove items from cart, clear cart, checkout process. Let's see how to model this. So now we know the participant, we know the activities. Let's create and group API methods. Like, what does it mean? Let's talk about it. So the consistent process that we have to go through is like this. This is how I identify. First one, identify participant. Then I identify their activities. Then I revise. If it's everything is okay, I made sure that those are really the participant and the activities. I go to the next step, break into steps, and I revise again. The revision is very important. And then create API definition. I revise, at the final stage is validating your API, and this is very important. And you can see that I can go back, and then go forward again in order to finish. So this is a consistent process that I have always to follow and to go through. So let's review, because we are forgetting. Those are our participants, those are our activities. Now the second one is to create an API definition. So to create an API definition, we have to identify the resources, which the resources is going to be affected. So I have a simple paper, and I do this like, yeah, we have described, we have item resource. By the way, the resources are the nouns always that you have in your system: item, order, customer, cart. So those are going to have actions applied upon them. So in the items, we would like to list items, view items, search for items, add and edit items. And we have a cart, and we would like to add item into cart, remove item, clear, view, checkout. And we have another, which is order, and we would like to apply these functionalities. And finally, we have the customer, and the customer, we would like to view if I'm a customer support, search for specific customer to get their orders, and finally add and edit customer, and this is going to be handled by the customer support. So this is how I identify the actions on resources. So now, after having the participant, actions, and resource, now we need to do the final activities to mapping our activities, I told you, to nouns and verbs. What is verbs? So the resource life cycle, I mean. So how to manage the resource that we have identified. Take discovered action to finally map actions to HTTP nouns and verbs. What is the verbs? Are get, post, put, and delete, or batch, and the others, or head. So on simple paper, I draw this and just write it, or in my board, or with the team on board. We have item resource. We know what we would like to do with activities. We have to list items. It's very easy. I can use get and slash items. And okay, view item, because it's now singular, so I have to have use get, but from items, I would like the specific item with a specific ID. This is super nice. And what if I would like to search for item? I will use the same URL, same get. Here there is the consistency of the naming, and provide search parameters. And what about adding an item? Yeah, I can use post and just the same URL. So finally, if I would like to edit, I will use the same view item, but I will change the verb to indicate that I'm editing a specific item. So you end up, after this, only one URL with different verbs that can serve your functionality. I know that most of you know about this, but it's very important to have it like this. Okay, now we are finished. Same for cart, but cart, why I have examination question marks here? Because we have a resource called item, which would like to interact with a resource called cart. And we have to identify the relationship between those. Same like dependability, and we're gonna talk about. And checkout. Checkout doesn't have any resource. It's like a verb. So what we can do with this, we will see. We will get back to it. Let's finish the other resources. So listing order for customer, it could be like orders. Yes, I would like to get specific order for the customer. Obtain order status, I can use the same URL. I would like to cancel, so I delete using the same URL, and that's it. For orders, customers are the same. So we have a consistency. So you can see that I always use for the resource ruler, customers, because it's always, if I just get customers means get all the customers. If I'd like to get specific customer, I provide a specific ID from that customer collection. So this is the meanings, and this is how we follow it. Let's get back to the cart and resource and see. In order to map remaining activities to custom actions, which are those, let's understand first the designing relationship that we have and to understand in order to identify this. So we have three types here. So we have independent. The resources may exist regardless of the other existence, but they may reference each other. This is very important. Or sometimes it's same like database concept design when we have foreign keys and parent and child tables. and we need to make the foreign key as nullability or enforce it, which is cardinality ratio. So dependent, one resource cannot exist without the parent. Associative means they have more information when they are interacting with each other. To understand this, let's see this. Can the resource, we have to ask our question, can the resource exist without another? Does one resource only exist when the others exist? Does the relationship between them have more information? If we would like to take an example between movies and actors, you can see that movies always at the beginning and actors, and we have character. Yeah, character is in, it's not independent, they are dependent because there is no character without a movie, and there is no character without an actor who playing this character. But there is a movie and there is an actor because actor can play more movies, and the movie will already exist with more, actors, and the character only specific at in this movie by that actor. So this is the relationship. So definitely I cannot put character as a, this is sub resources, so they cannot exist or served without or managed as a resource life cycle without the parent one. So I hope this example gave you what is the dependability is and how they should appear in the URI. So if we get back here, so we can have item, yes, item exists regardless of the cart. So we have carts because you already have it whenever you have a customer, and we can just use it like this because they are independent. And then the cart, because the cart always there but empty, and items already exist with represent the products, so they are already exist without the cart, so they have association here. Then we can just, because we are managing the cart life cycle, so we will start with carts and specific cart, please add this item or delete item, or if you'd like to delete the cart, we have managed this. And checkout is a verb, so please for this cart ID specifically check it out. So if you would like to validate, now we are finished, we have the resources, let's do the development. You can see that I just lay it out on paper and without just having any development yet. So this process is applicable for any language, for whatever it is you are using, or any approach, but just a way of analysis. So then at the end, you have the contract, you can distribute it, and that is agreed upon URL, verbs, and everything with the client, which is even client external or internal. So we are writing each resource action on note card, using note cards and filling the gaps. So let's validate our challenge. So what we will have to do if we are trying to handle a missing order, yeah, we can do it. And reorder the same order as the last time. Those are new requirement and our cancel part of an order. Let's see, solution. My order is missing. So the customer service lists the customer order. We have this functionality, customer service, obtain the customer status. We can do this functionality. So we have nothing new here to add. Okay, reorder the same order. So the customer view the previous order, we can do. Customer copies orders. No, we don't have this. Then we gonna add it. And customer checkout, we have a checkout process. Part of my order missing, customer views list of orders. Yes, we can. Customer service view the active orders, yes. And customer service cancel a specific item. We don't have this functionality, so we can add it for orders. So you can see here the validation, and for the requirement, if we have something missing, this is how it works. And then we get back to revise and add missing parts, then the full functionality works. So this is about modeling. Let's talk about HTTP in a quick. Yeah, it's a great tool. It's understood by most of the client. That tool there underlies the entire web. And REST is not a standard, by the way. It's REST is not a pretty, some URLs, not necessarily XML or even JSON. It's more than this. And it's not a standard, as I told you. REST is generally, as I told you, agreed upon or set of principles and constraint. We are going to have the constraint. It's something like SOUP versus REST, like a mortgage versus borrowing. In the mortgage, you have to go through a specific process in order to get your mortgage, then you buy your house or whatever it is. But borrowing, I can borrow you today $10, and in 2 days you can give me just $5, and the other day you can give me $5, or you invite me for a dinner or lunch. It's very cheap. Very nice. For $5 more. So there is no consistent process how I can give you back the $10. So those are the difference and comparison between soup and REST. So as I told you, it's a very powerful and understood protocol. So those are we have the response and the payload. And from this response and payload, we have to focus on headers and response codes in order to design really very well one, a REST API. So we have these tools in order to get the information about the request and response, and you can have it. So we have specific headers we are interested in, which is status, content type, and media types. And those are the most important headers that we need to take care of and mention when we design our API. And also response coded. We just use 100 for informals, 200 success, 300 redirect, and 4 for client error, and finally server errors for 500. But not all of the codes. I usually use those when we working with 200s. So okay, created, accepted, and no content found, which is not found, and that's enough. And also when I have changing an API, I use 301 or 302, and for 400 I use those only. That's always enough. We can use more, but those are always enough and well understood by most of the client. And finally, response code are great. As I told you, please do not create your own. Do not confuse your customer, because when we rely on the standards, they would be much more understood. Finally, I hope to cover those because of the time, but those are the most important. The rest constraint, as I told you, we have discussed the principles, and those are the constraints that should reside in each API design. Client server, stateless. Your API should be stateless, cacheable, using e-tags or whatever caching mechanism. Layered system, code and demand. This is the only one optional, and the hardest one, uniform interfaces. Client server, so like web server and web browser and web server. So by separating the two, we can vary them. How? Serve the scalability and reliability. We can add in the middle, many layers without affecting the REST API or whatever it is. I can put like many other servers to take care of the security and things in between, and I don't have to take care. So we have to separate them, and should be stateless. I don't have to have state even. Why? This is a great part, because when you have a stateless API, each request stands on its own. I can vary them. I can change the request order to achieve more functionality. But if I have a state, I have to go through the request API into sequence, which is not preferable. And also, I'm serving just the service, the request that I'm just dinged for, and then I don't manage really any state. And this way, scalability is much great. I can scale my application without worrying about session or something like this. This is why we use JW2 for security here, because it should always, serve the stateless of the security even here. Request can be processed in any order, as I said, because sometimes they will, believe me. So as I told you about this, like security token and everything, you have to identify it in each request. So you have achieving here the stateless for security. You don't have session anymore. So we are stateless. Why? Flexibility, as I told you, stability, and also reliability. This is about stateless, caching and cacheability. This is sometimes important. Each message should describe whether it's cacheable or not. Improves network and application usage, I agree, and makes the system more reliable and scalable. Yes, because if you just get shut down for some times or something, or scaling, your message still on the client side cached for some certain time, and it would be served without any problem. So cacheable, get, put, and delete should be idempotent or safe. So what does it mean? The word safe here means that if a given HTTP method is invoked, the resource state on the server will remain unchanged. Yes, if I trying to update the same content again and again and again, I can just first time always, based on I return to you, done. You don't have to wait for me to say I updated. I can take your request, put it in the queue, and I return to you 200. I did it. You know, it's done. Delete. Whenever you delete, you never delete the same resource from different. It's have been deleted. So whenever you call it 200, it's deleted. Even if there is no resource exists. Get is the same. Whenever you get, I will get you the save. But for post, no. I have to wait for an action to make sure that the resource is really created and I return you a state. And this is why it cannot be cached. We can use e-tags. They are very simple and awesome. Most of the framework like Spring and Java support them in the REST API calling and generation for response. And they are generated for individual requests sent in the header, compares to see if everything has changed or not, available via head verb also. And for more information, you can get here into this URL. And something like this, if I curl my GitHub, and you can see that e-tags here have this, and it will be caching your request and response for some times based on the the time specified, the max age and everything, cache control, using cache control, and it will be in your browser or something like this. Last three are very important. And then first, layer system. What does it mean? Don't count on client interacting directly with the server. Means I prefer to use DNS names, not IPs. For example, don't expose your IP to your client to interact with you, and you have to layer it. Same like I have this problem many times with IT in previous companies, and we are relying on the IP of the database, and then suddenly we are crying. We cannot achieve our tests. We cannot achieve like our startup of our application. Why? Oh, they are migrating to the new server and they forget to, to give us the new IP. And then we have this loop. So suggestions, let's have names, TNS names. So yes, give me a name, and I don't care whenever you change the IP. So this is one of the examples. We use this on a web every day. You will never interact with any company or URL or integration mainly with an IP address. You have to have a name, DNS name. And this is adds silent invisible dependencies, which is very nice. Layer system, why? It's allow in between system to add and remove functionality. This is something really nice. Allow load balancers, caches, logging, authorization, etc. to be in without interfering or changing the IP, because you have, to change the IP to the load balancer, change the IP to the caching system if they are in front, or API gateway. Because of this, no, just they can be in the middle without any problem. Cache on demand, this is actually nightmare, and it could introduce some, but a request does not just retrieve the resource, but also code that acts upon it. It's security hole, could be. But sometimes we have it, but we have it every day because Google Chrome do it, Google Gmail do it for you every time. Whenever you update, they just give you the new interface and functionality with alongside the JavaScript code that act upon and allow the functionality. Sometimes you have to do this. It's really allow for flexibility and upgradability. So I can just give you the code to update the new functionality without any interaction from you to integrate with the new functionality that you have provided. So yes, executing third-party code is a security nightmare, I know, but sometimes we have it. So like, yeah, I told you, Gmail, who doesn't use Gmail? Almost all of us. So last one, it's very, very, very important. Uniform interfaces should be present in every API. Believe me, it's most the complex, but most powerful at all. So uniform interface principles, identification of the request. What does it mean? It means what I told you before. Generally, we use nouns and then the IDs, or noun action IDs, but not required to have noun equal noun as a search parameter or filtration or something like this. Be consistent. This is very important to be identification of the request. Manipulations of the resources through the representations. What does it mean? Something like this. This is a Twilio API, just only 3. You don't have to introduce bunch of URIs to do many functions. So if you are visiting Twilio, you can find this. This is at early stages of 2010. Can you imagine? And this is like, I would like to get the recording for this account SID. I'd like just the calls and the security token. And this is the recordings, and this is for SMS, specific SMS if you would like. That's it. That's all. The 3 URLs serve all the company purpose if they have. So, and then you can get all the recordings, SMSs, calls, post only for calls and SMS, there is no update. Definitely you cannot update the recording, calls, or SMS, and delete only for recordings if you would like to do. That's it. This is the manipulation. How can I manipulate my resources? Just overdose. Self-descriptive messages. The naming. Each message should tell you if the resource is cacheable, how to process itself, how to request the next resource. This is very important, and not everyone taking care of it, and we will see. And to enable this, we are using hypermedia as an engine for application state, HATEOAS. So what does it mean by HATEOAS? This is like a bunch of text. I get it from, Wikipedia, but let me explain an example for HATEOAS. So I'm requesting at a bank, and I say, okay, this is my request for the bank, and the bank decided to have new functionality or something, or the resource, and what I would like I can do. So the bank is very intelligent to implement HATEOAS in their API, and they say, okay, you are just asked for your account, and it's very nice to have, okay, here is your account number, here is the balance, but hey, you can also make a deposit, you can make a withdrawal and transfer, and here is the URIs or URLs that you can achieve through them, these functionalities, and you can close your account also if you would like to. So what does it mean? It means that my system can provide more functionality through this, like HATEOAS URLs and everything, and for you just observe it. And I didn't break your existing response, because if you don't consume it, it doesn't matter, but you have it, and it's for upgradability and adding functionality. Description of the resources is very, very important and a powerful aspect. So if you call HATEOAS for API GitHub, you'll find like all of this kind of information, what you can do without contacting the developers, without contacting the server documentation, and what I can do. Like here, current user URL, okay, I can get it through this. Current user authorization HTML URL, I can use this, and I can provide client ID, nice, and just the feeds, the events, the emojis, the emails, I have issues, whatever it is, I can just use these URLs, and with this filtration, it's very nice description. So I can just, from calling your top API, I can understand how I can interact with you without even contacting you or reading your documentation even. So this was about the risk design, and was our goal about the risk design, the constraint, the principle. I told you, most of you, I know that you know it, but it's usually here, not an easy to achieve when you have a bunch of requirements. It's very easy to achieve when you have 3, 4, 5 URL or proof of concept, but when you have a big system, as we do, you have to make sure, even revisiting the new functionality, how it could be achieved, what is the sub-resources and the normal resources, that the life cycle, the process, how you can lay out, how you can provide yearly documentation and contract for your clients before even you develop the actual. Sometimes we go for swag, like contract first. If you, this is when you have a greenfield. I do this because sometimes I would like just to provide this, but I hate code generation, so I don't use code generation mainly for generating the REST API. I just would like to give a contract for the people. For versioning, sometimes, yes, we can do a lot of versioning, security. We are using JWT for security in order to achieve also stateless behavior, and this is all about. So if you have any questions.
Hello, I'm here to help you with the questions, but in the chat I don't see any questions.
So let's have your future questions on my Twitter account if you would like. Let me get you the previous slide for this so you can have. This is the one, and the Twitter account is not here.
It's not.
I will.
Okay.
I will write it on the chat. So I just submitted, and those also you can send me an email, comment on GitHub if you'd like. All the proof of concept best practices of this has been implemented into projects on GitHub. So it acts as a reference implementation for my team, for anyone I would like to explain. So you have everything. Thank you very much, Andrea, for having me.
Thank you
It
too.
was definitely my pleasure to enjoy talking to Romanian folks. Thanks for Andra and the other team members for inviting me as usual. And this is my pleasure. I wish you all a good day, weekend, and everything. Be safe and have a nice conference. Lovely
Thank you.
conference.
Thank you.
Have a lot
Thank
of
you.
lunch.
Have
Great
a good
people.
day.
Thank you.